Hey everyone, it's June 30th, Tuesday, 8 a.m., and I'm just beginning our lab for this week. There is only one lab this week, and it's projectile motion, and it's specifically projectile motion with PhET, which is an online website that has some really good computer programs that allow us to simulate experiments that we couldn't otherwise do. So this was ideal for when we had COVID, but we're still using it as a projectile motion lab for our online labs. Uh, Hopefully, you'll enjoy it and you'll learn a lot about projectile motion. This lab is mostly for the purpose of augmenting the course material as opposed to, learning experimental technique and stuff of that sort. So, however, it does have some of that as well because you're going to do some of the same stuff you always do. So, with that in mind, let me go ahead and share my computer screen with you so you can see what I'm looking at and we'll discuss the lab. Okay, so this is lab week 7 lab module. I actually do have a week 7 lecture module here, but it's empty right now. I'm in the process of filling that, so that should be done sometime today. But the lab that we're doing this week, as you can see, is week 7 lab module, June 29th to July 5th. This is the lab projectile motion PhET. I've actually got it opened up in another window. So this is what it is, and what we've done is just basically taken the lab that we had for our projectile motion and we altered it a little bit. As you can tell, this is our old equipment list for when we were doing the lab manually, but now that we're doing it in a simulated fashion, we don't need these things, so we just struck right through them. So what you do need is a computer. Obviously, you have one if you're watching this more than likely, except maybe your phone. You need Excel spreadsheet, which you have access to automatically as a student for TCC. You also need access to the PhET website, and potentially you'll need to download and run the HTML file. Most of the time, I can run it straight from the website and don't have to download. But if you have any problems, it's best to just go ahead and download it and do it. This is a link, of course, if the link doesn't work, which it has, and it did this morning, then all you do is look for this projectile motion and simulation. That's what you're looking for when you get to the PhET website, which I'll show you in a second. But let's go ahead and click on this and see if the link actually works. So I just opened it to a new tab. Now I'm putting it here, and you can see that that's the actual website you're going to, and you can look and see it says simulations and projectile motion. Uh, this is all the stuff that comes with it. Here's teaching resources, which you wouldn't necessarily have any ability to deal with. Here's activities, translations, people that wrote it, so on and so forth. But the main thing is you're going to run this program, so you can just click on this and start running from here. There's the intro, there's the vectors, there's the drag, and there's the lab. If you click on intro, you can see how it works. Notice we have an initial speed that can be varied. Notice we also have a different angle or that could be fired. And the way we do that angle is we just move this up and down. But every time you fire, you do this and see how it just hits exactly the same spot. That's again because it's a computer program. It doesn't have the random fluctuations of randomness of how well compacted the spring is, how well behaved the spring is, friction forces, all that kind of stuff. So, what we're doing here is showing you the various parts of the lab. You can angle it up, you can angle it up higher, you can even angle it down to some extent, and you can move this around to see what length and what height, or excuse me, what high distance you want it to land away from the cannon. And you can also, of course, raise this cannon height up and down as well. So even if you wanted to do 0, that would be launching the projectile from 0 height, and then you can try various angles. Uh, Looks like they might not let you go below 25 degrees for projectile motion from 0 level. But you could also do from 1 meter, and then that would let you go all the way down to even negative angles. So 1 meter is not too terribly bad, but that's basically it. As I said, you can move the target, you can erase stuff like that, and this is how you fire. You can change the initial speed either by that or just by moving it with your mouse button. But that's how this lab works. You can actually add air resistance. You can show velocity vector, the total velocity, are the components. You can show the acceleration vectors. Uh, let's say the components here, and let's say the components here. And now I'll put it in slow-mo, and let's launch and watch what happens. So you can see that the velocity components, the x component stays exactly the same throughout the whole projectile motion. Oops, let's fire it again. Oops, let's do clear that. Okay, fire again. See how the velocity horizontal component never changes. The vertical component changes. It goes from positive to negative and stuff of that sort. But so let's erase again and let's fire again. Now you see the acceleration, the yellow vector, that stays a constant pointing down. The velocity component in the vertical direction starts off vertically and then shrinks down to zero, and then it flips upside down and grows, pointing down, while the acceleration vector just constantly points downward. So you can actually use that to get an idea of exactly how to understand how to solve the projectile motion problems. That's exactly the stuff we taught you, that if you're ignoring air resistance, the x component of velocity doesn't change at all. The y component, of course, does change by 9.8 meters per second each second it's in motion. And then, of course, the acceleration, once the projectile has been launched, in other words, you've gotten rid of all the forces that caused it to take off and fly. Once you've done that, it's in free fall, period. There's nothing different about it. The acceleration is constantly 9.8 meters per second every second, pointing downward, right up until it hits the uh, landing, at which case it, of course, does all sorts of weird stuff. It could bounce, it could break, like it seems to show here, so on and so forth. So that's the PhET website. Of course, that I'm just showing you the intro site, if I remember correctly. But we can also go back to the vectors, so we can look at that, or we can talk about drag, or we can do the actual lab. And you can see this is a meter stick or tape measure, basically, that you can take down and measure specific distances and all sorts of good stuff like that. This is something where you can find out information by clicking on the projectile at any point in time. All this stuff is super helpful, obviously, for when you're doing the labs. But this is another lab. You can do cannonballs, tank shells, golf balls, baseballs, football, pumpkin, human, piano, car, so on and so forth. You can change the mass. You can change the diameter. You can change gravity to match other planets. You can increase air resistance by adjusting the drag coefficient. All that stuff is fair game. So that's just some of the stuff you can do with this PhET website projectile motion portion. So now that we discussed that, you can see with this lab, you're just going to click on the link below, and this will take you there. The screen will look like this, and you can see we're going to projectile motion, and it says if click on the play button and click on the intro button. If the play button does not work, then click the download. So when you got there, you're supposed to go to the intro, which is what we're here, and then we're supposed to hit the play button, which is that one. Of course, we right want to erase it first. And then you can fire that. That shows the actual projectile motion. We're watching it in slow-mo though. But then you can go back and pause it and play and so on and so forth. Uh, the screen will look like that. Of course, they have their projectile launching from a height of 10 meters. They've got the statue of David there wearing a bathing suit. You can adjust the vertical distance. You can leave the speed at 15 meters per second right now, but they want you to click and drag the target to the 14.3 meter mark, and so on and so forth. So it's just a procedure that you do. The big thing about this is the learning how to program your Excel spreadsheet, and that's what happens here. So you're supposed to read through these instructions and fill out this data table, and once you have your Excel spreadsheet filled out with these numbers up here and these column headings and you put in this number, then all of this should pop out by itself. When you put in 5, this should pop out. When you put in 10, this should pop out. If once you've programmed your Excel spreadsheet and you put in these numbers and these 0, 5, and 10 degrees, if you don't get these numbers, then you know your Excel spreadsheet is not done properly. So that's sort of the purpose of all this. Once you've done that, once you've got that and you verified that these numbers are exactly the same as yours got, then you can go back and erase these and put in the actual data that you use here when you take these different distances and angles. So you're going to actually, once you get this all set up, you're going to test with 15 meters per second at these various angles and see what the distance is and record it. Then you can put those angles in here and see how the theory matches the data, because here, this will be the data column for distances, and this will be what the Excel spreadsheet predicted using kinematics that we learned from projectile motion. Here's all the formulas. They tell you how to do it. And this is basically the exact same lab that we did in class, only in class we did it with an actual projectile launcher, something that you don't have access to at your home. But you can see, because we're doing the exact same process, this clearly has some value for our lab's perspective as well, because it's mostly helping you use your kinematic equations to understand projectile motion, but it also is having you analyze the lab like normal. So you got to write code to some extent, write formulas to some extent, that is, to fill out the Excel spreadsheet. That's prediction. And then you've got the experimental techniques of how do you compare X theory to X data, so on and so forth. So it does have a lab component, even though it's mostly meant to subsidize your education and projectile motion. So its main purpose, of course, like I said, is just to help you better understand the material. They tell you how to graph the data, select the data, and as always, when you do a lab report for me, remember any calculations you make by hand, you have to show me one sample calc for that. Any type. That means if you do an average of distances, then you want to show me, and you show me a sample calculation of calculating the average distance, and then later you do an average speed. You don't have to show me a sample count for average speed because you already did an average. If you did a standard deviation, you show me one calculation, but if you did another standard deviation or two more standard deviations later, you don't need to show me any more as well. But all of those calculations need to be done roughly where they either tell you to do it or where you're in the lab that you're analyzing it and you're forced to do it. And I want it put in right there. Normally the lab will say show sample calc here or show your calculations here or something like that, but I'm actually asking you to do a little bit more calculations necessarily than what the manual and the document does. So make sure you do that. Every calculation you have to do by hand, I want to see one sample calc of that type. If it's the same type, like an average of two different quantities, I only need to see one of those. If it's an average of 12 different quantities, I still only need to see one of those. Same thing with a standard deviation, percent error, percent difference, that sort of thing. But if you do have a percent error and you have a percent difference, I should see a sample count for percent error and I should see a sample count for percent difference. And again, like I said, I want them put in either right where they tell you to do the calculation, which would normally be like in the procedure or the analysis, and also, I want to see pictures of all the graphs and any tables you have, and you want to put them right in the lab document where you were instructed to do it or where you had to do it. So again, that means normally in the procedure or within the analysis section or something like that. This one, of course, has questions like a lot of them do, and you have to answer these questions. Remember, all the fonts that you type in have to be a color other than black. So you can use any type font other than black. Be careful. I don't want you using a color so dark that I can't tell it's different from black. And be careful. I don't want you using a fluorescent color that makes it impossible for me to read or gives me a headache to read. So I would stick to like a medium green or even a darker, like almost a hunter green or a medium blue or a darker blue or even a lighter blue would be fine as well. I prefer not red just because sometimes I have to use red to make grade adjustments, but even red I wouldn't necessarily take off. I just prefer not to have that. Yellow is not a choice I would want to see. Brown wouldn't be a problem, so on and so forth. Again, the main purpose of this not having any black font is so that I can immediately look at a document that you turn in and know exactly what you wrote in versus what the manual already had in it. So if you put in numbers here, you either need to write them in by hand. Oops, don't know what happened there. Okay, you either need to write them in by hand. Oop, that's not it either. That's not it. Okay, so it just closed that window on me. I'll open it back up. So you either need to write them in by hand or you can type them in, but if you type them in, they have to be a font other than black. So that's what that's for. Again, you're going to use this just to uh, set up your spreadsheet, and then the data that goes in here will actually be your real data, not the data that's here. That's again just for the testing process to make sure your Excel spreadsheet's made up. Also, you have to, I want to see, like, if you have multiple graphs and you have to decide which one is the best fit, which you're not going to do on this lab, I want to see at least one other one that you chose not to use so that I can have some understanding that you really understood why not to use it. And that means sometimes you'll have more graphs than the manual tells you to, and that's normal. Okay, so I want you to do that. Always err on the side of you giving me too many graphs, but never, never, never put them at the end of the document. So I don't want to see sample calcs at the end. I don't want to see uh, data tables, and I don't want to see graphs at the end. I want to see them in the location of the lab where you were instructed to make them, or in the location of the lab where you were instructed to analyze them, not saving them all to the very end. Once all that stuff has been input into this Word document, you're going to save it. This time you're going to save it with your name and something about the lab. You might say projectile motion or PhET, PM, that would be fine, all in the name of the file. And then you're going to save the file as a PDF instead of just a Word document. And that's what you're ultimately going to turn in. So hopefully that makes some sense and you understand that. This is where you're actually going to turn it in. And normally I have all the instructions written here. I usually do that after I post the lab. I haven't done that part yet, but you can see if you ever forget, you just go to a previous lab. Like if we look at the very first lab on lab week one, lab module, you'll see if you click here, this has all those instructions that I just finished telling you about, putting all the calculations in, the photos, and all that good stuff. This is that introduction. I use pretty much the same one every time. So it's just a matter of me cutting and pasting from the previous lab into the current lab for you to do that. But that's it. We're now done with the intro to projectile motion using PhET, and I'll be posting this video in a few. I was hoping some people might show up for office hour, but that's okay. You're never required to. But remember, this is an option for an office hour or assistance with lecture material, or even just to ask questions about the syllabus. So I hope that clarifies things for you, and I hope you're able to progress nicely on the lab. Remember, we're only going to have one lab this week, so that means Thursday there's not going to be a lab. If you need me, I could still come in at 8 a.m., or we might even try a different time. Just let me know if you need help. We can make that happen. I can treat this 8 a.m. slot as a office hour where I can answer any kind of questions you might have on. By that time, everybody should have finished test two. So if that's all done, then I can even answer questions on test two, and of course, I can still answer questions on test one, meaning the face-to-face test, that is. But I could also answer questions on the online test. I can answer questions in the practice test, all that good stuff. So if you have any of those specific questions, it's best that you go ahead and take a screenshot of the questions that you had, and the screenshot should include not only the question, but if it's a multiple choice, include the answers too, so we can see which one is the best answer, because sometimes there'll be more than one right answer, and what you're supposed to answer in a multiple choice is the best answer among all the answers. So, anyways, I'm going to stop sharing and call it a day. Y'all have a good one, and contact me again by email or text message if you need anything. And I should be grading some more labs today. Hopefully, you can learn from those labs and then change any labs you've already turned in that I haven't graded to be consistent with what you learned from the grades, the labs that I did grade. The biggest thing right now is that students are not listing on the front page, even though I know this is online class and the vast majority of you are not working with another person. I still want you to have name, your name, and then lab partners, colon, and say not applicable or none or put in your lab partner's name. Okay, that has to be on the very first page, and I took off 5 points the first time for not doing it. All subsequent ones will be taking off even more points. Like right now, I'm up to 10. I might be taking 15 next week. So make sure you, as a bare minimum, correct that on all the labs you turned in. I'm only going when I go to grade the labs, I only take the latest downloaded version or the latest uploaded version, I should say, and then that's the one I grade, and then I put the comments in and post a grade there. So hopefully you guys can learn from the lab reports that I have graded already and not make the same mistake in future labs. So have a good one. Thank you. Bye bye.